I'm Dave Rothery. If you've been following the course, you should recognize me, though maybe not the shirt, from the tidal heating video. With me is Jess Barnes, who's been your course guide. And joining us from Houston at the Lunar Planetary Institute is Christine Shupla, who you also recognize, I hope. Hi, Christine.
Good afternoon, everyone. Hi.
So now we're in week 3 of the course, and we really hope you're enjoying it. In week 1, we asked you to post any questions that you might have on the first 3 weeks of content of the course.
Following the course, you should recognize me, though maybe
throughout the course, and we're going to try and get through as many of those questions in the next 45 minutes as we can. You can also post any questions that you might have now. You can post them live on Google Plus using the Hangouts group chat option. You can also post anything on Twitter using the hashtag FLMoons14QA.
Now, the main point of these Hangouts is to answer your questions, but there's always something happening in the world of planetary science, and especially to do with moons. So each time we're also going to give you some news about what's been going on. Now, it so happens that the 3 of us, just 2 weeks ago, were all at the same conference in Houston, the Lunar and Planetary Science Conference, which is the premier planetary science conference in the world, about 1,000 delegates, and there's a lot of good science talk there. So, Christine, what from the conference was the most outstanding talk from your perspective?
Well, there were many that were outstanding, but the one that interested me the most personally was one that talked about, well, there's this really large crater on the moon, South Pole Aitken Basin, that goes all the way from the south pole of the moon to the equator, and it was about trying to date how old this crater is. And some of the estimates, some of the data suggest that this crater could have actually formed from an impact that occurred before the moon finished solidifying, while it was still covered with an ocean of lava. And to me, that was just amazing.
Wow, that's really cool, really interesting.
Yeah, that was good. Jess, what was the highlight for you?
I think for me, it definitely was something that happened just before the conference. It was a micro symposium that was held on the Saturday and Sunday before the conference. And on the Sunday, they had 2 Apollo astronauts talking. So they had people who'd actually walked on the moon, set foot on the moon. And they even had someone, they had Dave Scott, who was one of the astronauts on the Apollo 15 mission. And I've recently done some work for my PhD looking at a Apollo 15 sample. So for me to see the man who'd actually collected that sample from the moon, another celestial body, was like mind-blowing. So that was definitely my favourite bit. Yeah,
Dave Scott gave us a great talk on the Wednesday afternoon. And I hope you've seen my little video selfie I did with Jack Schmitt, the Apollo 17 geologist. It was great to mix with the astronauts.
Definitely, yeah. What about you, Dave? What was your highlight?
Well, the thing that struck me most was a talk about Titan, this large satellite of Saturn with a dense atmosphere, but it has considerably large seas, filled largely of methane, with some ethane, and these have tides. And the modelling of the tides that a chap called Ralph Lorenz has done suggests that in this sea here, you probably can't see it very clearly, but the dark areas of the seas, Kraken Mare has a northern part and a southern part, and they're linked together by some quite narrow straits, about the width of the Straits of Gibraltar, and there should be tides going from one end of the sea to the other. And in the constriction, in the narrows, you should get tidal currents that are quite fast. You should maybe get breaking waves, maybe whirlpools. A bit like the Corryvreckan race off the coast of Scotland was the analogy. And if you were there, you would hear the tide rushing to and fro in the narrow bit of Kraken Mare. And I thought that was an amazing thing to imagine. One day we'll go and see it. Okay, now back to the course. Thank you, all those of you who've been participating so well. We've been really impressed by the number of postings, not just the questions you've asked us, but the responses in all the discussions. I mean, the discussion we asked you early on about what do you think would be the significance of finding life on Europa, that had a very lively response. You'll find out much more the reasons why there may or may not be life on Europa as the course progresses. I suppose apart from the Europa discussion, the thing which really caught people's attention was this. Now, this is your fault, Christine. You said anything smaller than a toaster can't count as a moon, anything bigger can count as a moon. So what do you say now to everybody?
Well, as you pointed out, David, it would be very difficult to see a moon the size of a toaster in orbit. So if you can't see it, does it really count?
Yeah, I think you're right. There have been a few fairly indignant posts saying, why hasn't the International Astronomical Union got a grip on this situation and made a definition of what's a moon and what isn't a moon, in the same way as it a few years ago made a fairly strict definition about what can count as a planet and what can't. I think the issue is toaster-sized moons are too small to see. You can see rings made of toaster-sized and finer particles, but you can't map an individual object. So individual moons less than 100 meters across, we don't have the technology to detect anyway. So it's a moot point what the lower limit should be, perhaps.
And I think they'll probably be forced to define it once we find one that's going around the Earth, that they have to decide what it is.
I think you're right. We don't need a definition until we need it. Okay, let's go on to answering questions. We are receiving live questions. We're looking out for them, but there are plenty that were posted in step 3.2. So first question I have here is from Dave McQuarrie, who says, will Saturn's rings eventually disappear, say gravitationally lumped together and form moons? And why does the Earth have no rings despite the giant impact theory of the moon's origin? Christine, what do you say to that?
Well, it's entirely possible that rings could eventually disappear and change over time, because we know that the orbits of some of the particles around some of the gas giants and some of the moons even aren't particularly stable. And some of the modeling, Robin Canup over at Southwest Research Institute had done some modeling for the formation of Saturn's moons that suggest the rings that suggested they may not be that old, that that they may not have been there for billions of years. In fact, I think the question is still open, though.
But do we think that they could clump together to form a moon? I thought the point about Saturn's rings is that they're too close to Saturn. There could be a moon that was ripped apart.
And that's why they disintegrated into the ring material.
Yeah.
That was part of her model, was that that there perhaps at one point had been a moon, that as it got closer and closer to Saturn, its outer layers were ripped off, and the core that was left probably fell into Saturn.
So Saturn may lose its rings, but the rings won't form into a new satellite because it's too close to Saturn to clump together, because you'd be pulled apart tidally. The near point of a moon to the planet and the far point of a moon to the planet would be so far apart in the gravity well that there wouldn't be sufficient strength to hold together. Once you get too close inside the Roche limit, bodies get pulled apart.
Indeed,
that's pretty much it, yeah?
Yeah. So let's move on to the next question. We've got one from David Foster, and he's asking, Phobos is shown as a potato shape with a massive crater caused by an impact on its edge. This is in step 3.26 of the course. And the impact, the crater, is called the Stickney crater. And he's asking, why didn't the impact that caused the Stickney crater also cause Phobos to spin?
Okay, well, Phobos is in synchronous rotation, as almost every moon is, as it orbits the planet. Stickney is about a fifth the radius, a fifth the diameter of Phobos, so it looks big, but you've got to remember that the impact which caused that crater is going to be about 30 times smaller than that. So it was a relatively small impact, and it may have changed Phobos's spin, spun it up a bit faster, but it wouldn't have taken many thousands of years, perhaps, for Mars's gravity to grab hold of it again and slow it back down to synchronous rotation. So I think this is it, isn't it, Christine? Stickney looks big on Phobos, but the impactor, relative to the size of Phobos, is not all that big.
And I don't know when the impact that created Stickney happened. Did it happen before Phobos was captured by Mars?
That is, I think, unlikely, because it depends on the grooves on Phobos and how you interpret them, but some of the grooves on Phobos overprint Stickney crater, and if the grooves on Phobos are caused by Phobos as it orbits Mars, I can use my balls now. If the green one's Mars and the blue one's Phobos, as Phobos goes around Mars, if there's an impact onto Mars throwing ejector out, Phobos will travel through the ejector and leave machine gun bullet traces on it, and those overprint Stickney. So Stickney appears to have formed after Phobos was captured by Mars. I think that's how most people would read it. But the origin of the grooves on Phobos is not proven. Okay. Another question, yeah? Sarah Price has asked, how are you able to tell what a moon is made of from such large distances, and what the inner core of a planetary body consists of? Christine.
I love this question. This is one of my favorites. Anyone who's ever received a present that was wrapped and tried to pick it up and shake it to figure out what was inside was using some deduction based on the weight, based on how things move, the sound. Well, astronomers and planetary scientists, geologists, use some of the similar techniques to try to figure out what's going on inside of a planet. We look at the outside, we look at the spectrum, which is like a fingerprint to tell us what the planet's made of on the outside. But on the inside, we're deducing it based on picking it up and shaking it in a way. As a mission goes around a planet, it's measuring the magnetic field that tells us a little bit about the inside. It's measuring its mass, its volume, and its density, and then it's almost like picking it up and shaking it, trying to figure out what's inside.
Yes, because you know the size of something, and you can measure its total mass because of its effect on an orbiting body or a spacecraft passing by, you can work out its density. And if its average density is greater than the density of what you can see at the surface, it has to be something denser inside. I mean, that's how we know the Earth's got a dense core. Now, we have other evidence on the Earth because we've got seismic waves and so on. But the moons, we just have to make reasoned deductions. We know what the solar system is made of. We can see the common material. You know, the core of the moon, the tiny core of the moon, could be titanium, but titanium is pretty rare. Iron is much more likely, but we can't prove it.
But we make a best guess.
We make a best guess, yeah.
And we do have samples from the interiors of asteroids that were broken apart when we get meteorites. So that gives us some clues as to what they were made out of. That also gives us more evidence.
Absolutely. Meteorites tell us what the solar system is made of.
Indeed, yep. Okay, let's switch over to the live chat. So we've had one post on Twitter. Don't forget you can get in touch with us via Twitter using the hashtag FLMoons14QA to keep those questions coming in. So we've had one from David Blanchflower, and he says, do you think that the giant planets, Jupiter and Saturn, are capturing new moons at the present time? Good question.
I think probably they are, very infrequently. Jupiter and Saturn have scores of small outer moons. We're not talking about capturing an Io or a Europa or an Enceladus, but these small moons, usually in retrograde orbits, that look like they've been captured. Now, there are icy bodies wandering between Jupiter and Saturn and Uranus, and every so often, one of them, or particularly if it's a double body which passes a giant planet, one of those can be captured. And I suspect that some of the outer retrograde moons probably are captured bodies. Yeah. It's an infrequent event, I imagine, but I don't think the process has stopped. But the big satellite, the big moons, we're not going to grow another big moon, I think. Christine's nodding.
I agree. And the thing that amazed me was those massive orbits of those little captured bodies that are out there. Some of them take years to go around their planets, which is hard to imagine.
Well, people playing moon trumps will find some moons which take a long time to go around. While we're talking about these bodies between Jupiter and Saturn and Uranus, gives me a chance to mention Chariklo, the thing that's been in the news just this week. It was announced that a body has been found, it's a Centaur-class body between Saturn and Uranus, an icy body, and it was realized it was going to pass in front of a star and occult the star, and that's the best way you have of measuring the size of these bodies, by how long it passes across a star. So this group of Southern Hemisphere observatories in South America watched this occultation and saw the star hidden by Chariklo going in front of it briefly, but to their surprise, just before and just after, the star dimmed twice, and it's got extremely narrow rings going around it, which is a 200-kilometer body, an icy body, with narrow rings around it. And because it's got, rings were a surprise, but the narrowness of the rings suggests that Chariklo also has moons to keep those rings in shape. They wouldn't stay so tight unless there were some shepherd satellites. Now, if Chariklo came close to Saturn, it would be quite easy for Saturn to grab one of Chariklo's moons and steal it for itself, probably. You can't steal a single body going by, because you can't rob it of all its momentum. But if you've got a double body, you can grab the smaller one, and the bigger one will go away a bit faster. So there's a moon of Saturn in the just waiting to happen. If Chariklo goes too close to Saturn, one of its unseen moons could be grabbed by Saturn. So thank you for that question, David. Very, very useful.
Very much.
Okay, another question from earlier. Chris Cox writes, have we been able to gather any information on moons in other solar systems? Now, this is a good point. I've seen it raised elsewhere. We know many planets around other stars, but have we ever found a moon of another planet? Christine, anything to say?
Moons are too small to detect with our current technology going around other planets. The planets themselves are pushing our technology to the limit. So to be able to detect a moon at this point, I don't think is possible.
Yeah, I agree, but to my surprise, I was talking to one of our exoplanet experts here at the Open University, and she says we're not far off with transits of a planet going in front of a star. If it's got a big enough moon, we might spot a separate dip as the moon goes across the stellar disk. It's not been done yet, but we're not far off seeing really large moons around transiting planets. So that we should expect moons.
Yes.
But it will be a challenge to find them. We won't know much about them, but just to see that they're there would be nice, but not yet.
Not yet. Waiting. Okay, we've got another question here from previously from Sarah Jorgensen, and she's asking, how does gravity have anything to do with pulling moons into spherical shapes?
Go on, Christine.
Well, gravity, all the moons have mass, and so that mass is pulling everything towards the center of mass. And so if you take something, any object, and you start to pull everything towards the center, you're going to form a circle or a sphere if you're doing it in 3 dimensions. So you'd simply need an object that's massive enough to have enough gravity to have it become more of a spherical shape. So that's why planets are round, and that's one of the defining characteristics for a dwarf planet, is that it has to be somewhat round. It has to have been massive enough for gravity to have made it sort of round. If it spins fast enough, many objects aren't perfectly round, right? Saturn, if you look at it sideways, it's wider than it is tall. It's spinning a little too fast. And so, yeah, it's not always possible, but completely.
Gravity is the main thing which tends to make bodies spherical. I mean, Sarah writes, how does gravity have anything to do with pulling moons into spherical shapes? Well, gravity is the main thing which makes something spherical. If a body is too small, it doesn't have enough gravity to overcome its strength, and it can be whatever shape it happens to be. But if you're an icy body, more than a couple of 100 kilometers radius, 400 kilometers diameter, you're not strong enough to resist your own gravity. You'll have to pull yourself into a sphere, unless you get too close to a giant planet which rips you apart. Is it my turn to read a question? Yes. Okay, so Jay writes, for planetary scientists as a community and also as individuals, which of the gas giant moons appears most promising in the search for life, Europa or Enceladus? Well, this is a moot point. We had to make a decision when we were designing moon trumps, which I hope you've been playing online, and you will find, my glamorous assistant can hold up the large versions of the cards, you will find that in the potential for life category here, well, it was my fault, I opted for 50% potential for life on Europa and only 30% on Enceladus. Other people may put them the other way around. I think most people would agree Enceladus and Europa are the moons most likely to host life. Yep. They're the most habitable. Europa is bigger. It has a global ocean probably under its ice. It has quite a lot of heat in its rocky core. Think of Europa as a less hot version of Io covered in 100 kilometers of ice and water. So there's much more energy to support life in Europa. Enceladus, we do know, has water because it has these eruption plumes. It's a smaller body. The thing we don't know, and you'll come on to this in the final week of the course, although these have places that would be habitable for life, could life ever have got started there? That's the big unknown, and that's why it would be significant to find life in Europa. If we ever do find life in Europa, unless it has somehow got to Europa from Earth or been seeded from Mars, and Earth was seeded from Mars, so if we can rule out the common origin, then if it started independently on Europa, then we're talking about life starting twice in the same universe, even in the same solar system. If it can start independently twice in the solar system, it must have started many times elsewhere in the universe, because there are bound to be places just as habitable as Europa and Enceladus and the Earth elsewhere. But we don't know how easy it is for life to get started. We do know it's quite easy for there to be places where life could exist if it could ever get started.
Habitable zones, or whether they're inhabited.
Yeah, there's a difference between habitable and inhabited. So that was a good question. I don't know that the community would agree with me about which is the most likely to be inhabited, but Io is not there, and Enceladus and Europa are right at the top of the list.
There are top choices.
Yeah.
Okay, let's go back to the questions we've had from before. We haven't had any more on the Twitter, so I'll just remind you of the Twitter feed again. That's hashtag FLMoons14QA, and you can also use the Hangouts group chat app, which is at the side of the screen at the moment. So please use those to ask us any live questions, and we'll try to answer them as best we can. So next question is from Ray Ball, and that's, I remember reading an article some years ago that said the Earth had another very small satellite at quite some distance away with a diameter of around a mile. Is this an accepted fact? And if so, is it just a captured asteroid fragment, and is it still in orbit? So Dave, any thoughts on that one?
Okay, well, I do have some thoughts. It was on QI a while ago. No, the Earth does not have another moon. There are one or two strange asteroids that orbit the Sun in 1 year, so they are close to the Earth. Their relationship to the Earth is rather strange. They're in so-called horseshoe orbits. They get ahead of the Earth, and then they lag behind the Earth. But they do not orbit the Earth. They go around the Sun. The most famous of these is known as Cruithne, or Cruithne, depends how you pronounce your Gaelic. It is not a moon of the Earth. It orbits the Sun, close to the Earth, and takes a year to go around the Sun. Well, sometimes close to the Earth, sometimes far from the Earth. But on average, it takes a year to go around the Sun. It doesn't orbit the Earth. It's not a moon, neither or any of the other candidates. Am I being controversial there or not?
I don't
That's
think
what
so.
I've heard as well.
Yeah. So still one moon for the Earth.
Yeah, believe me, don't believe Stephen Fry or the QI elves. Okay, question from Simon Hodgson. He writes, in an old Observer book of manned spaceflight, accounts of the Apollo landings, because they left seismometers behind, talked about twice monthly moonquakes. Are these genuine phenomena? Christine?
Absolutely. We know that impacts on the moon are occurring regularly, and those can cause moonquakes. And as you pointed out, David, so can tidal forces from the Earth on the moon are also causing moonquakes. We don't think that that the moon has active volcanism. We don't think that there's massive movements in the moon's mantle or core that would be making it tectonically or geologically active anymore, though.
Jess, you're a moon expert.
Almost. Yes, quite right. Who sent that in? Simon. We do get moonquakes, and they're actually really deep. So they're thought to have come from anywhere between 800 and 1,000 kilometers within the moon. They're also asymmetrically distributed across the moon's surface. So we know that most of them are actually concentrated on the near side of the moon. But there's one called A33, which is actually on the far side of the moon and has an antipode on the near side. So it's not exactly known why there's asymmetry, but that might have something to do with the asymmetric nature of the moon itself, of its layering system. And what causes them, again, isn't quite known, but we know that they coincide with cyclic tidal periodicities. So that is another reason why I'm going to put a little plug out there that we need to go back to the moon and we need to set up a seismic network.
Yeah.
Any thoughts, Dave?
No, other than to agree that the best way to find out about the inside of any planetary body is to put seismometers on the surface and When anything hits it, you can pick up the vibrations from several places, and that will probe the internal structure. And that's what we need to do on all the planetary bodies.
Yep, definitely.
Except for the gas giants.
Yeah.
You can't do it on the gas giants, yeah. Okay, Dean Sheridan has asked, is there any evidence for other moons or planets having tectonic plates currently or in the past? And if not, why does the Earth seem to be the only such special case in this respect? Christine?
I really like this question as well. This is one of my favorites because it highlights some of the ways that the Earth is really special. We don't have any evidence for any other planets having plate tectonics. Other planets don't have strings of volcanoes like the Earth does next to subduction zones there. We don't see spreading zones to the same extent we see on the Earth. Some of that evidence might have been covered up. If Venus ever had plate tectonics, volcanism could have covered it up potentially. And there's people who are actively researching whether Venus ever had it, and there's some iffy stuff there. And some of the icy moons also have what looks like plates that behave in some ways like plate tectonics with their ice crusts. And there's dispute right now, from what I can tell, among the community as to whether that really could be called plate tectonics or not. But Earth is special because of our size, because of our density. Earth has enough heat within it to generate the plate tectonics we see. And Mars is cooled off, Mercury's cooled off, and there's something wrong with Venus, and it's very different. So Earth is special.
Yeah, as a part of the Earth, the lithosphere is lubricated by a weak zone, which is possibly because the Earth has water which is taken down through subduction. It's a bit of a circular argument, but once you've got that, you've got a weak zone and plates can move around. Venus lacks this weak zone, so even if its outer shell was broken, it couldn't glide around so well. There was a talk at the Lunar Planetary Science Conference 2 weeks ago about subduction zones on Europa, where if the icy crust on Europa is being broken apart, then you may imagine one plate being forced down below another. I wasn't convinced by it. I think things work differently on Europa, but it's the closest analogue we perhaps have to Earth, like plate tectonics. But the more we study solid planetary bodies like terrestrial planets and the large icy moons, because they're solid largely, the more we realize that they have things in common but have a surprising number of differences as well. So planets don't have to be like the Earth. So this is why it's important to study these places. Yep. We're understanding the universe.
We are.
Any more live questions?
We've just had one actually, a really interesting one from Graham Bloomfield. So thank you very much for sending this in. Can we look for life on Europa without risking it? And if so, how can we do that?
Without risking it? Well, it's if life on Europa has an independent genesis of life on Earth, there's no reason to suspect that you'd kill it by infecting it with a bug from Earth. Likewise, there's no reason to suspect that we'd be killed by Europa plague if we brought stuff back, because why should things infect organisms to which they're completely unrelated? But I think there is a risk of contaminating the European biosphere, if it exists, by accidentally taking bugs from Earth, microbes, which could survive when they got there. Now, you're not allowed to deliberately crash a spacecraft into Europa. There's a COSPAR protocol, it's a Committee on Peaceful Uses of Outer Space, I think COSPAR, international body anyway, which says you mustn't crash anything onto Europa unless it's as devoid of microbes as you can possibly make it. And that's less than 100,000 microbes per square meter of surface, which is not exactly microbe-free, but that's as clean as you can make anything. You can't remove all life. Nope. So the rules are that it must be only a 1 in 100 chance, but you'll infect anywhere. So eventually, if we keep visiting Europa, we're bound to infect it with life from Earth. But at the moment, when a mission goes to Jupiter, it is not allowed to just be left abandoned in Jupiter orbit. It is crashed into the planet or crashed somewhere else to avoid the accidental risk of it hitting Europa. And the same protocol's in place now. The Cassini mission that's orbiting Saturn will not be allowed to run out of propellant while it's orbiting Saturn, just on the off chance that in the future it might crash into Europa Enceladus and contaminate its biosphere. So when Cassini reaches its end of life, it will be crashing into Saturn to stop it ever happening. So there are rules in place to stop accidental contamination. I don't think we'd ever kill off an alien biosphere by taking terrestrial bugs, because they shouldn't compete with each other. But we certainly don't want to blur the boundaries of what's there naturally and what we've taken ourselves. Otherwise, we won't understand what's going on.
And we definitely don't want to do that before we know if there is anything there. So we don't want to send any bugs there, leave them there, and then go back to try and find bugs and find our own bugs.
Absolutely. Christine?
I agree.
Okay, let's go to another pre-made question.
Well, this is a related question. Susan Allam writes, with regard to Europa and life, it suggested that some life could develop around cracks, in particular photosynthetic life. How long would those cracks be open for? And wouldn't they have to be open for a long time for plants or other organisms, or plants or other organisms to evolve and grow? There's 2 habitable niches on Europa that have been identified. There's possible hot water vents, black smokers on the floor of the ocean, where life could live off chemical energy, and that's maybe where life began on the Earth, so it could begin there on Europa. There's also, in Europa's icy crust, there are cracks, some of which we think open and close with the tides. So that's every couple of Earth days, cracks would open and close. They'll only be a metre or 2 wide, but when the crack is open, water will rush upwards, and you'll have water exposed to sunlight. Provided you're more than a centimetre or 2 down, you're shielded from radiation, but you do have enough life for photosynthesis. So life could exist there. Now, it would only be a few hours per 2-day tidal period when it was exposed to the surface. When the cracks close, the water and the floating algae or whatever will be pushed down. But a few hours every couple of days is surely enough for life to exist. So we would hope that life could survive on Europa in those circumstances. We don't know. A misconception that I've spotted in the posts in the course is that people are saying, well, surely the surface of Europa is too cold. It's below -100 centigrade. And that's true at the normal surface, but when the cracks open, relatively warm water comes to the surface, and it will start to freeze over at the top fairly quickly. But while it's still liquid, it's not at -100 centigrade. It's at 0 centigrade, or a bit below if it's salty. But life can exist.
That might just be the conditions that it needs to survive. What do you think, Christine? You're nodding your head there.
Well, there's so much that we don't know, right, about the boundaries, but we know that we've found bacteria living inside of seas encased in ice in Antarctica on all sides. So yeah, it's entirely possible. The only question I have is how it would evolve. Would it have the materials it needed to evolve in the first place? The ingredients, but.
Yeah, I mean, they're not very tempting places for life, but they're the most habitable places beyond the Earth. Well, no, you're not a microbe.
No. Very true. Okay, let's move on. Let's take another live question, because we've had loads of questions coming in, and we're really grateful to you sending in all your questions. So we've had one here from Brian Jones. How dangerous are micrometeorites to astronauts? So that's a good question. Let's go to Christine, see if you have any insights into this.
I think that micrometeorites can be very dangerous if you're out on a spacewalk. It could puncture your suit, and so it could be very dangerous. I suspect that they go through training where they try to patch small impacts like that, and you could have similar micrometeorite impacts if you're walking around on the moon unprotected.
Definitely, or even just hitting spacecraft, and what effect that has, I guess we don't know yet. But Dave, thoughts?
Well, micrometeorites are dangerous, but they are few and far between, fortunately. Some people are posting about the impact flashes on the moon. This isn't micrometeorites, but we've shown you maps of recorded impact flashes where cameras are trained on the unilluminated part of the moon to see flashes when a meteorite strikes the surface and it is heated and vaporizes and leaves a glow. Yeah. Now, and those it looks like there's loads of those on the moon, but the moon's a big place, and these are making craters only a few meters across. So most of it, you'd be unlucky to be hit by anything on the moon.
Yep.
But if we ever go there and build infrastructure intended to survive
then we
for
would need to
decades, then it's a risk you have to take, because the moon has, those things would burn up in the Earth's atmosphere, but the moon has no such protection.
Exactly. Okay, another question about Europa and Enceladus. What are the chances of ESA or NASA sending a probe to one of the icy moons of either Europa or Enceladus? And what kind of tonnage are the volcanoes on these bodies pumping out on a weekly basis? So that's two different questions there.
Okay, I looked up the tonnages and forgot to bring the piece of paper with me, but it's about 2,000 kilograms per second coming out in the plumes on Enceladus, and about 4,000 kilograms per second coming out in the plumes on Europa when they are active. Mm-hmm. We've seen them just a few times. We don't know how persistent they are. Sounds like a lot, but if they kept churning out that much material, it would take 10 times longer than the age of the universe to empty them. So there's plenty of stuff inside these bodies. They're not going to run out of material. They're not shrinking. So that's how much stuff is being ejected. About missions, well, there was to be a joint NASA European Space Agency mission to Jupiter called JUICE, which is still going ahead. NASA pulled out of that a year or two ago, so it was planned to send a European mission to Jupiter, which will end up orbiting Ganymede, but it will make a study of Europa by some flybys as well. So that's going to happen. So that's Jupiter Icy Moons Explorer, and that will be in the 2030s sometime. But just a month or so ago, NASA announced it had changed its mind and was going to send a Europa orbiter as well. There's not enough money being ponied up yet, I understand, to build and launch it, but there's a lot of money for a study, and who knows whether that will get there before the European one. Do you have any light to cast on this, Christine?
Europa is one of the top targets of interest. And part of the reason that Europa is a higher priority than Enceladus is simply Enceladus is much further away. Europa is a top target. It would be very expensive to send a mission to primarily study Europa. You would need a mission that's strong, protected against the magnetic fields, and capable of slowing down and going into orbit around Europa. It's an expensive mission, but it is a high priority. I suspect that it will happen. The question is, will it happen in 10 years or 20 years or 30 years?
Yeah, most missions to be out of solar system always seem to be 20 years into the future, sadly. But they do happen sometimes. We've got a wonderful mission in Cassini, still there, still observing the Enceladus plumes.
Something to look forward to.
Okay, more questions. We don't have very much time left. Margaret Greening writes, do the effects of surface gravity or atmosphere make any appreciable difference to impact or speed? Who wants to take that one?
I'll start. The surface gravity does. The gravity of a planet will change the speed at which something is approaching. And one of our scientists, Dr. David Kring, has put together a grid, a graph that kind of shows the higher speed that an asteroid will hit the Earth compared to the speed that same asteroid would hit the Moon with because of the increased gravitational pull of the Earth.
Okay, but atmospheres, I mean, a large body coming into the Earth isn't even going to notice the Earth's atmosphere. It bores a hole straight down and bang. But small objects, meter-sized objects, aren't going to get through the Earth's atmosphere, but they will hit the Moon. So there is a size bracket where the atmosphere will have an appreciable effect, but big objects don't even notice it.
Yeah, just stream on through.
Yeah.
Okay, let's go back to the live questions on Twitter. We've had one from Josh Andrews that says, is Earth unusual for having a large moon, or is the inner solar system likely to be unusual for lacking moons? Tough one.
Well, we don't know why Venus and Mercury don't have moons. No. I mean, if the Earth was struck by a giant impact to produce our moon, that's a fairly unusual event, so it doesn't have to happen everywhere. And Mars's moons are captured asteroids. The other part of the question is is the Earth unusual in having such a large moon? Well, the only other body, large body, which has a moon of similar size is Pluto, which doesn't count as a planet anymore, but its moon Charon is even bigger relative to Pluto than our moon is relative to us. Yep. So the Earth-Moon double planet is less of a double planet in relative sizes than Pluto and Charon are. I don't think we know enough to say how common moons are on terrestrial planets around other stars yet, and will be a long time before we find any of those, sadly, I believe. Yeah, Christine's nodding.
Yep.
Okay. Right, somebody asks, David Foster asks, I've already asked one of David's, never mind, you get 2 goes, David. Where did the ice, ammonia, methane and such like come from in such vast quantities as found on Europa, Enceladus and Titan? So why are these volatile ices out there? All right, I'll answer it. Actually, there's not a lot of ammonia and methane on Europa. We get the more strange stuff out at Saturn and beyond. So Jupiter, the ice is very largely water ice. And the reason it's there is it was cold enough at Jupiter and beyond for these things to condense. Get into Mars and closer to the Sun, it was too hot when those bodies were growing for ice to condense. So you don't have a lot of water on the Earth, really, compared to what you've got in Jupiter and in Jupiter's moons. Further from the Sun, it's even colder, and that's where you tend to get the ammonia and methane as well. So there are vast quantities of these volatiles. It's no surprise, because the most common element in the universe and in the Sun and the nebula from which the Earth and all of the planets formed is hydrogen, followed by helium, which doesn't react, and oxygen is one of the next most common. So hydrogen and oxygen make water. Nitrogen's common. Put that with hydrogen, it makes methane. So these things are common. So it's common substances. Gases are more common than, or gases that form ice are more common than things that form rock. So when it's cold enough, that's what you get. So we think we've got time for one more question.
One more question. Okay. Okay, let's take the question from Doug Bliss, which is, when a meteor impact on the moon causes a bright flash of light, is it possible to use spectroscopic analysis of the color of light to gain information regarding the chemical constituents of the objects involved? And this is quite an interesting one.
Yeah, it would be a good thing to do. I'm not sure. These flashes of light are not very bright.
Nope.
You have to keep video cameras staring at the moon even to spot them. I bet somebody will try to do it. Of course, you would get the chemistry of the moon mixed with the chemistry of the impactor, but in principle, you can do it. There was a deliberate crashing of a space probe into the moon.
It was the L-Cross mission, yep.
And part of it, the initial flash of light isn't just going to be from the materials from the impactor. A lot of that is also going to be the vaporization of the moon itself. So you would probably get a mixture of the two, and depending on the size of the impactor, you might not see it at all in the spectrum, I guess.
Somebody's bound to try it. I think it'll be challenging, but somebody will try it. Well, I think we've run out of time. Thanks for all the questions. I'm sorry we couldn't get round to all of them. So that's it from me and Jess and Christine. This should be live on YouTube shortly afterwards, and if you're watching it on YouTube but not live, I hope you've enjoyed it.
Yep, and I'll be back in 3 weeks, where I'll be joined by Professor Simon Kelly from the Open University, and also, we've just learned, Professor Paul Spudis from the Lunar Planetary Institute in Houston. So that's going to take place at 7 o'clock British time on Thursday the 24th of April, so we really hope you can join us then. So thank you very much from all of us here. See you in 3 weeks.
Thank you.
Bye.